Recess or well, my name is Miss Loveless. Nice to meet you all. I'm going to teach your math lesson today. Super excited about that. You guys had a good group of school this first week. I think we started in school. Right. So let's talk about what we're going to do before we're going to get started in just a second. But I'm going to talk about the stuff that's on your desk. Okay. They have dry erase markers that they can write on these. Yeah. Sheets with yes. Okay. So you're going to be working in groups of 3. So let me tell you where those groups of 3 are before we get started. So you guys will be a group of 3. You have some stuff. You guys, I guess you're a group of 2. You have some things. You guys will be a group of 3. You're going to join them in a minute. When I say get in a group, you'll just slide your desk over, or not desk, the chair over to them. Okay. You guys will be a group of 3 right here with your stuff. And let's see. We got you coming over to this group. So in a minute, you can slide over. Let's see. So that from you. So we can either do a group of 4 where you can just join this group, or we have a group of 2 up there. You're welcome to move either spot for our groups. Is that good for you? All right. Any questions about where your group is going to be when I say get into groups? You probably only need 1 marker for your group. So if you want to get that out, that'd be great. Let me tell you a couple of expectations I have for math while we're doing math. Number 1, I expect you all to be working on the problem, to solve the problem. Okay. I expect you to be sharing the manipulatives. So you have some place value chips here that you're going to use to do the math today, and you have a place value chart that you'll use to write on today. Okay. And that you work together, that not just you do it all while he sits and watches. So if there's a group of 3 that you want to take turns using the manipulatives and helping each other. Okay. When we come back together to do share and discuss time, when I'm showing some of your work on the screen, I will ask you to turn and talk. And so I want you to go ahead and think about, point to who you're going to turn and talk to. And I say turn and talk, preferably one other person. But if it's a group of 3, that's fine. So go ahead and point to that person. Who's it going to be? You know who you're talking to. Go ahead, y'all look are excited. Are y'all not very excited? You're excited? Well, me too. All right. So these are your turn and talk partners. That's who you're going to turn and talk to when I ask you to do that. Y'all got it? Are you ready to roll? Yep. Awesome. Okay, well, here we go. Let's get started. So today you're going to be exploring how to represent multi-digit numbers. So I know last year in 3rd grade, you learned a lot about 2nd grade. You learned a lot about numbers and place value and what those things mean. And so you're going to pull all that knowledge that you have stuck back in here that you might not have thought about in a while and use that to help you represent a multi-digit number that I'm going to show you. Okay, you're going to know you've learned the lesson today. You're going to know you have been successful today when you can represent that number with models and with an equation. So you're going to think about, how can I model this with the chips? And then what does that look like with an equation? Y'all with me? Think you can handle those? All right, well, that's what we're going to do. So here we go. So John says all the 2's in this number, 222,222, are the same value. Do you agree? So I want you to think about that for a minute. What you're going to do is use those place value chips to model that number, recording the value of each digit in the place value mat. Okay? So you're going to model and then record the value. But remember, our success criteria is to be able to model and write those equations that might match those. All right? Are you ready to prove if John's right or not? Yep. All right. Open up your bags of chips and get started. And I'll be coming around asking you some questions. The marker for your place value chart. You need to write on that. So if I ask you to move to another group, go ahead and move. Maybe they're going to work as a group of 4. Do you want to work as groups of 2? Y'all can do that if you want. Like if you 2 want to be a group and you 2 be a group. Totally up to you. Or do you want to work as a group of 4? Okay, let's do 2. Why don't you slide over with her? Bring your manipulatives. And you guys be a group of 2. That way you can work together. All right, so y'all work on that and then I'll come back to you. All right, let's see what you got going over here. Tell me about your model. Tell me what you got represented here. Okay.
There's 61. Well, yeah, because I have to.
Okay.
Yeah. 2 and 3. We need 2.
Okay. All right. So your partner here put all this on here. Can you guys tell me why did she put 2 of each chip on the chart? Oh, so how did she know to put 2? So all the 2s tell you need 2 chips from each value. So John said that they're all the same, that these 2s all represent the same amount. Do you agree with that? No, you don't think so? Okay, so remember, part of our success criteria today is to write that as an equation, but also right here it says to write that as the value of the digit. So I want you guys can work together to write the value of this, because you just said this is 200,000, this is 200. So I wonder if you can write the value of the digit, but remember, what would that equation look like to show the value of that digit? So y'all talk about that and I'll come back and check on it. Okay, so how did you get the value of the whole number? So I'd say you've written the value of each digit. So how do you find out the value of the entire number, 222, 222? Okay, so if I said, if you're going to show me the value of that number, if you have 200,000, 20,000, 2,000, 22, how do you say that number? Okay, so how did you get that? What would you do to all of these values? Oh, add them together. Okay, so you said you're putting 2 here because the digit tells you you need 2. When you say 2 what? Okay, can you use the word groups up to tell me that you need 2? So use the word groups up and say you need 2 groups of 100,000, right? And this would be 2. Got it. You're following that? So here's what I'm wondering. Remember, part of our success criteria is to write the equation to represent this value. How can you use what you know about groups of to write an equation that would show this value under each one? Y'all talk about what would that equation under each one look like, and I'll come back to it. All right. Let's find out what you got going here. Okay. Okay, so the 2s. So what do the 2s tell you? Okay, that there's 2. Can you use the word groups of and tell me 2 groups of? 2 groups of what is that? Okay, 2 groups of 100,000. I'm following you. So tell me why you have 4 here.
We would need one more.
Two ones, okay. Okay, so when she says the other 2, what does she mean by that? You know why she has this other 2 here? No? So talk to me about why she shouldn't have this other 2 here. She's saying she needs it to show the other 2.
Oh my God.
Can you help commit to otherwise if you don't think so?
Wait, I know how to make small.
You don't know? So why would you pick 2? Why did you pick 2 and 100 chips? So this number right here, this digit tells you there's 2 numbers. Oh, okay. So now what digit is this in? What place is this digit? So what kind of chip would you need to show that?
Hold on.
Awesome. So y'all keep working on that. And remember, I want you to write the value. It says to write the value under each one. So what is this worth? How much are these two together? So I want you to write that value. And then don't forget to think about what's that equation look like for each one. So go ahead and finish modeling. Oh, talk to me about your model.
She said the value of each together.
Okay, so the twos tell you what? Okay, so there's two chips needed for each digit. So use the word groups of and tell me that you need two. Okay, two. Okay, so two groups of each of those, right? So remember, part of our success criteria is to write an equation to match those. I'm wondering if you know what you know about groups of. To write an equation underneath this to show me how you got this value, saying two groups of something. What equation could y'all write to represent two groups of 10,000? Okay, y'all talk about that. I'm gonna come back. All right, talk to me about what's going on over here. What about all these tips? Did you model? Remember, part of our success criteria was to model and then write an equation. So did you model it? Nope. So what? Oh, they were. Okay, so what would the model look like? And y'all too, since you're here, what would the model look like? Y'all, since y'all both look like you have, let's talk to both of you. What would you put here in the model?
And you said two.
Okay, so she says two of those. But he's saying he would go ahead and write what you would write. So he's writing the value and she's saying two of these. Who's right, y'all? He's writing that. She's saying two of these. Who's right? You're both. Can you both be right? Tell me how you're both right. Oh, did you hear what he said? Both of these equal 200,000. Would y'all agree? Yep. So what I'm wanting you to finish out is finish out your model, kind of like I put it down here in model. And I want you to think about what you just said. You said two of these make 200,000. Right? So if I was asking you to use the word groups up to tell me about this, what would you say? This is two of 100,000, she says, right? So I want you to use what you know about groups up to write an equation underneath it. So you have your model, you have your value, but what's the equation that would represent 200,000? I want y'all to think about that. Y'all work on that. So you guys have your model. Talking about why you chose to put these in two of each of these. They are all two, right? So those twos tell you what? Two, use the word groups of to explain what you need. Two groups of what? Two groups of 10. Yeah. So if you were thinking about your two groups of, right? Remember, part of our, it says on the board of digit, we need to write the value of this digit, but on your success criteria, you always also have to write an equation to show this value. So how much is this worth? What is the value of these two chips? Can you write that for me? And you guys can work on writing the value. Go ahead and write that 200,000 there. It's hard to get it all in there, isn't it? So knowing what you know about groups of, what equation would you write underneath each of these to show the value? Y'all talk about that. I'll come back check the equation, right? You guys got an equation in for me? So I noticed that you wrote 1,000 plus 1,000. Right? I have to write this to make it open. To show 1,000 and 1,000.
Or you can just suck on it. You could do times.
So I like what you said, 1,000 times. I wonder if you could write all of your equations. Let me take a picture. If you could write all of your equations using a multiplication equation like you just said. Y'all work on seeing if you can shift that. And I'll come back. Okay. So talk to me. Let's talk to these two groups at the same time here, because y'all look very similar. Okay. So you can kind of shift yourself so you can listen to our conversation. So you all have it written. You all have the values, your 200,000 and your 2,000. Why do they have plus signs between each of theirs? Why do you think they have plus signs between each of those?
I do. You add them all together.
She's adding it all together. Oh, like the expanded form, yeah, yeah, like you guys have done many times before, right? So got the expanded form, and you, they all have twos written here. Why do they have twos written? Okay, it's the number of each what? Place value, right? The number of each place value. There's 200,000s, right? There's 10,000, right? So when you guys are thinking about what this means, if I was to say use the words groups of, tell me what this 2 means. You have 2, use the word groups of, say 2 groups of, and you have 2 groups of 10,000. So what I'm going to challenge you to write underneath each of these, where you have your values, and you're saying John is wrong. Those values are different. Did y'all prove John is wrong? Yeah, they're not all the same, are they? They're all the same. The value would be the same on all of them, and they're not. So what I want you all to think about as your little individual groups, what equation could you write underneath each of those to show 200,000 as an equation for 2 groups of? What operation is groups of? Talk to your group about that. What's the operation you can do to show an equation? No, talk. That's what people are going You have 6 and you have 12 groups, right? But if we're talking about that, does the 6 groups of 12, all the groups have the same value? So when you write 6 groups of 12, it would have to be that 6, every group has a value of 12. Does every group have a value of 12? Now, what does the group have a value of here? You have how many groups? 2 groups of. What's each group worth? 10, right? So can you write an equation? Addition, subtraction, multiplication, division. Which operation is groups of? Yeah. So what would that look like? 2 groups of what? Can y'all work on that with an operation? What operation do you think? What operation shows you groups of? Plus, you could add 2 groups together. Is there another operation? You have about 3 more minutes. Could you show multiplication for each of those in there? Show what that looks like. All right. Got your values down. So it's John 9. He said all the values are the same. What's the value of this? This is worth how much? 2. So can you just write the 2 there and show what that value is worth? What's the value of this? So 20. So the value is how much it's worth, right? This is worth. Gotcha. Yeah. So my question is. Oh, I see. I got you. Yep. But this would be 2,000, right? 2. So then I want y'all to think about that equation in our success criteria. What would the equation look like to show 2 groups of 20 or 2 groups? Could it be plus? Could it be something else? Besides addition. Could you use multiplication to show 2 groups of 10, 2 groups of 100? Y'all work on that. I'll be back. Is that okay? Multiplication. So you have your 2 groups of. So where's your 2 groups of 1,000? I gotcha. And this is. Okay, but remember, we're thinking about groups of how many groups are there? 2. So you always have to have 2 groups of, and then what's the size of it? So y'all keep working. All right, did you get your question? Did y'all get your question? Oh, look, they have written multiplication, and you guys have written addition. How are those the same? How are they different? Right. They are. So if we're used to language of groups of, which operation means groups of? Multiplication. So they wrote 2 groups of 100,000, 2 groups of. So let's look at this. Can y'all see this? Oh, can you fix those? Why did she change it? She wrote 2 groups of 100,000, and she wrote 2 groups of 20,000. What did she change? Right, now, you're right, but that's not how much that's worth. Good, I love that. So 2 groups of the 10 is the multiplication function, right? So what I'm wondering with these 2 groups is how many we had no 100,000 chips. I mean, not 100,000, 10,000, so sorry. What if we had no 10,000 chips? No, but you still have to represent 10,000. How would you represent 10,000? You have to put it all in these spots. So you gotta have 2,000. See if you can get that out. See that? What if you had no 1,000? Alright, so get your equations written. So you had your 2 groups of 100,000, 2 groups of 10,000. Oh, so that's an addition. They wrote 1,000 plus 1,000. How's that the same or different than yours? Did you get 2,000? Yeah. Did you get 2,000? You did. So you got the same answer, but how is 1,000 plus 1,000 the same or different than 2 groups of 1,000? Okay, so it's really the same thing, right? Just another quicker way to write it is 2 times 1,000, right? So what my question for you all is, what if your 10,000 chips told you you can't, you have none, but you still have to represent 10,000. What would you do with your chips to represent 10,000? Oh, you're gonna be totally different. Yours is gonna be 1,000 chips. What would you do to show that? So y'all work on that. I'm gonna now tell me why you get 2 9 stacks. How many stacks will it take today? I know they'll say, like, hold on. Why are y'all putting stacks of this? How many are in that stack? 10. 10. Why would you make 10 of them? Because I make 10,000, 1,000. Okay, so let's come back together and talk about some of the solutions that you all have shared. Here's what I need you to do. Tops on your markers. I need you all focus up this direction, and I'm going to show some of your solutions on the screen. Okay? Sometimes technology challenge. So think about our success criteria and our exploration today. Today you were learning to represent multi-digit numbers. Did you represent multi-digit numbers today? Yeah, you certainly did. You had to write the value of each of those digits in the multi-digit one. Did you do that? Yeah, I think you are definitely using that success criteria. And then I asked you to write an equation. So that's where we were in that process of writing an equation as I was walking around. So I want us to look at some of these. So what I need you to do so we can focus on our work here. Oh, I'm not in the right thing. It should pop up right here. Our broadcast.
Debbie, she got it last time. Give her just a second.
Okay. So there we go. So tops on your markers because we want to pay attention to what's up here. Remember, this is when our turn and talk is going to happen. And if I turn this timer off, put a timer on, it's probably going to change this.
Here, you want me to set a timer?
What would you?
How? 12.
12. Thank you. Now it's There we go. Okay, so let's start with this one. Maybe, let me turn it. Is that better for us? Let's see that. All right, so let's take a look at this solution. Is everybody looking at it? So at this time, we don't want to be touching our manipulatives or using our dry erase markers because we want to talk about some of the work that you all did out there because you did some fabulous work today. So let's take a look at this. Do you see this? So remember, we were trying to prove if John was right. John thought that the value of all of the digits in 222,222 was the same. And so we'll get to whether or not he was right in a minute. But I want you to look at that. Why did this group choose to put 2 chips in every one of those place values? Turn and talk to your group. Why did they choose to put 2 chips in each one of those? Okay, so come back to me. Who wants to share? Why did they choose to put 2 of each of the different chips in those? Yes. She said every place value had a 2 in it. Okay, but why did you choose all different colored ones? Like, I get that she's saying every place was a 2, so they put 2. But why didn't you put all the same value? Yes. Oh, did you hear what she said? Say that louder. Because it was the value of every group. So I think most of you did the same solution as some of this group. You chose 100,000 chips because the value of this place value is 100,000, right? And the digit told you there were 2, right? And so I went around and asked almost every group to use the words groups of to tell me what this meant, right? So part of our success criteria in our instructions was to write the value. So let's take a look at this. And let's see if we agree with this value. Where did this value come from? So this group wrote the value of the digits. They're working toward our success criteria. They modeled and they're writing the value. So they have 200,000, 20,000, 2,022, 20 and 2. Couple questions for turn and talk. Are you ready? Here's your questions. Where did those values come from? How did they get each of those values? What did they do? Right? And then how did you find the value of the entire number? So talk to your group about that. Where did those values come from of each of the digits? And how did you get the entire value? All right, let's come back together. So would you guys like to share what you were saying about how they came up with the value? She said these add up to 200,000. Is that what y'all talked about in your group? Yeah, keep going. What else did you do? So she's saying they added up to this value and that's how you got the value. Would you agree with that? Yeah, so what I asked you was, too, on top of that, where did these values come from? How did you get the value of the whole number? What do you have to do to all these values to get the value of the 222,000? Yeah. You have to add them all together. And somebody out there said it. You said it was what kind of number when we have these broken up in place value parts? When we add them all together? Yeah. Say it. Expanded form. Right. Y'all remember that? Is Barry back in here when you did expanded form? Probably not last year, but maybe the year before. Expanded form, when you had the value of every digit, you added it together. So tell me your name, sweetheart. Cora said that we added all these together to get the value. So I have another solution for you to look at. I think. Hang on. Here it is. And I want you to think about what Cora said. She said we had to add the values, add the chips together to get the value. That is not what this group did. Look at that. Look at what they have here. 100,000 times 2, 10,000 times 2, 1,000 times 2, 100 times 2, 10 times 2. Excuse me? I thought Cora said we had to add them together. Tell me, is this right? And if it is, why isn't it doing what Cora said? Turn and talk to your neighbor. Turn and talk to your neighbor. So it's the same mass, is that what you're saying? Okay, so come back with me. Would you like to share what you said? Would be great.
Basically like you're adding the two numbers already because times two is like two numbers and you adding them together.
Did you hear what she said? What was that word I kept those two words I kept asking you all to say or use when you described it? You remember? What was it? Groups up, right? So multiplication means groups up, right? Two groups of 100,000, two groups of 10,000, two groups of 1,000. So our friend in the back, tell me your name. Addison was saying, like Cora said, it's addition, but that's the same thing as multiplication, right? So either way, you're getting the value of the digit, but the group sub is going to be very important as you continue your work in this unit about writing numbers in expanded form in a different way. So keep that in mind as you're looking at these. So we know this is two groups of a certain value to get our value, right? So remember, as we were working and learning toward this, I asked some of you to represent the number. And this is what someone did. Okay, I need you to just take it in. Are you taking it in? Y'all see that? You following it? All right, try to talk to your neighbor. Why did they do this? Why did they do this? Why did they put these stacks there? They were playing with that? Yeah, what if they weren't? So you didn't have okay, so let's come back together. Let's come back together. I had a theory up here that they just played. What y'all think? Were they just playing? Oh, you think they maybe they at first it looks like they might have been just playing, but some of you said no, they weren't just playing. Who wants to share what they were thinking? Yeah, talk to us.
Like 10 of 100 is 1,000.
Did y'all hear what he said? 10 100s equals 1 1,000, right? So if we were going back to this, we have 1 1,000, but we could substitute that out for 10 100s. Do y'all agree with that? So then why do they have two stacks again? Yeah.
Because another 10,000 equals 2,000.
Oh, so we had to represent two groups of 1,000, and so we needed two stacks of those. Would y'all agree? Right? So you're telling me that there's 10 of those. So when I think about how this hundreds place is related to the thousands place, and we're thinking about times, if you're thinking about how many times greater is the thousands place than the hundreds place? I want you to talk to your neighbor. How many times greater is the thousands place than the hundreds place, and how can you prove it with this model? Talk to your neighbor. How many times greater? Y'all ready for this turn and talk one more time? I think I lost you there. So here's what you're talking about in your last turn and talk, okay? How many times greater is the thousands place than the hundreds place, and how does this picture prove it? Turn and talk. How many times greater is it, and how does the picture prove it? I heard 10. Why are you saying it? It's 10 times greater. Already said why those? Yeah. So how does that picture prove that the thousands place is 10 times greater? It took how many? Right. So if something's 10 times the size of something else, how many of them is one? So it's way bigger. All right, let's come back together. I asked you how many times bigger is the thousands than the hundreds, and how does this picture prove it? Who can talk to me about what your group said? Who wants to talk? Yes.
We said 1,000 is 10 times greater than 100 because you need 10 100s to make 1,000.
Oh my goodness, I don't think I could have said it better myself. You said that the thousands place is 10 times greater than the the hundredth place. Because what? One more time.
Because you need 10 hundreds to make 1,000.
Oh, 10 100s makes 1,000. So when something's 10 times greater than something else, it takes 10 of them. So what would we multiply 100 by? 100 by? What would we multiply 100 by to get 1,000? Would you agree? Because it's 10 times greater. Yeah. And we do that because we know that this place is 10 times greater than that one. It took 10 of them. I have one last thing for you to look at. Okay. And so you're telling me that the 100. Oh, go away. I cannot go away. There we go. It doesn't work when you tell it to go away, just so you know. Here is. Oh, did I not take a picture of the last one? Okay, sorry. Look, I'm gonna take a picture of the other one that I didn't take a picture of because they too did something. Hello, I can see. Can y'all see it up there? Oh, there we are. Look, there you are. Okay, so back to this one. Sorry, I thought I had taken a picture of it already. So remember what you told me on the last one. You said the 100 of the thousands was 10 times bigger than the 100. Look at this one. What could you say about the 10,000s place in relation to the thousands place based on what you see here, what we just discovered? Turn and tell your neighbor. Use the words times as many or times greater. There you go. So how is it? Which one's 10 times greater? That's 10 times greater than that. And this is 10 times greater than Okay, let's come back together. Based on what you all told me about our last question, y'all told me that the 1,000 was 10 times greater than 100, and then I said, well, what about this one? What does this one also tell you? Yes. 10 times 1,000, she just said, is 10,000. Would y'all agree?
Yes.
And then y'all told me a minute ago on our last picture, oh, that didn't work. On our last picture, that this was that 1,000 equals 10 times 100. Are we seeing a pattern here? Oh, there time's going on. So are you seeing a pattern here that this place was 10 times greater than this one, and this place is 10 times greater than this one? Is there a pattern? Why don't you talk to your neighbors about the ones we didn't show you, like the 10s and the 100s and the 100,000s? Can you make a prediction or a prediction about what you think their relationship is? Do you think it's 10 times greater on each of them? Turn and talk to your neighbor, and how could you prove it? How could you prove it if it is? Oh, did it turn the other way? Oh, I'm so sorry. So how could y'all prove that? So what she's saying, how could you prove it? What do y'all think? You think they're all 10 times greater? Okay, let's come back together. What do y'all think? What did we discover? What's your prediction about the others? Who wants to share? What is that your neighbor said? Yeah.
Because if you did 10 times as many, it would be 1 million or
If you did what times as many?
1,000 times 1,000.
Oh, on the 100,000, if you did 10 of those, he's saying that would be 1 million. What do y'all think? Yeah. So we keep taking 10 of each of these every time we go to the left. Doesn't matter what the place value is. It's a billion or a trillion. It's going to be 10 of the one to the right, isn't it? It's going to take 10 of the one to the right. Did anybody else have some other thoughts your group talked about? Yeah. Yeah. What'd you say?
That it's the same thing with all of them. You could put 10 of them and add 10 of them.
Yeah. Did y'all think about that and talk about that? So every one of these digits to the left is 10 times greater than the one to the right. Why? because you have to times 10. You have to take 10 of them, 10 groups of that. Remember our groups of language? 10 groups of this equals this. 10 groups of this equals this. 10 groups of this equals this. What a discovery you have made today about how much greater the one to the left is than the one to the right. So interesting. So when you think about our learning target for the day, when you're representing multi-digit numbers, you're rock it, right? Your success criteria was you had to model it and write an equation. What do you think? Did you write it? I feel like you did. You not only wrote equations for, you wrote the values and you wrote addition equation, multiplication equations, and then you talked about how this is the equation and the relationship. So you wrote like 3 equations. So you definitely got your success criteria today. But what we discovered today at the end of our lesson, you all told me that every digit as we go left on the place value chart is 10 times greater than the one right next door on the right. That is an amazing discovery you made today. Here's what I'd like you to do. If you would clean up your place value box or chips and put them in the bag, erase that, and then I have an exit ticket for you. It's not actually, there's a page in your book to do. Do they have their books nearby? They're in their desk. So once you get that all cleaned up, if you will have someone bring it up to me and we'll set it right here on this chair, and you're gonna get out your book and do page 5, number 1 and 2.